Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin.
Long ago, before glass became a bridge between human eyes and the heavens, the night sky was a mystery drawn only with the naked gaze. People would lie on their backs and watch the slow drift of stars, their light faint but eternal, their patterns whispering of gods, myths, and hidden truths. The eyes of humans could trace constellations, but they could not pierce deeper. The shimmer of stars was always just beyond reach, as though a veil of distance lay between the earth and the secrets above. And then came the miracle of glass, a substance born from sand and fire, fragile yet transformative, able to bend light into new shapes to focus what was once scattered. In its polished curve, the stars would one day reveal their secrets. The first glassmakers never imagined their molten craft would open windows to infinity. They shaped vessels, ornaments, beads that caught the sun. Yet within those shimmering surfaces lived the power to concentrate light. In time, curved lenses began to magnify the small, ants, grains of dust, threads of fabric. Curious minds marveled at worlds unseen by the naked eye. A drop of water, when viewed through a lens, came alive with motion, revealing the teeming dance of life too tiny for human vision. This was a foreshadowing, a quiet promise that glass could do more than beautify. It could expand sight, not just inward to the miniature, but outward into the vastness above. When light bends, it obeys laws older than the stars themselves. A lens takes scattered rays and draws them together, weaving them into a single point of focus. The eye, too, is a lens, its curved cornea bending the incoming glow of the universe. The telescope, then, is like an artificial eye, crafted by hands to extend the reach of vision, to let us drink in more light than our pupils ever could. And with that borrowed clarity, the cosmos begins to whisper truths that had remained silent through millennia. The first telescopes were humble tubes of wood and brass, their lenses ground by artisans who did not yet understand all the mathematics of optics. Still, they worked, turning faint glimmers into sharper points, bringing the moon's face close enough to reveal craters, valleys, and scars that no myth had ever spoken of. Suddenly, the moon was no longer a goddess, or a flawless pearl glowing in the heavens. Through the telescope, it became a landscape, another world with a face of stone, imperfect yet wondrous. Humanity's imagination trembled. For the first time, the celestial was earthly, reachable in thought if not in journey. And then came Galileo, a restless thinker with hands that shaped lenses and a heart that yearned for the stars. He lifted his telescope toward Jupiter, and what he saw made him question everything once thought eternal. 4 tiny lights orbited that giant planet, moons circling their master as Earth's moon circles us. If the heavens themselves contained motion and hierarchy, if other worlds had companions, then perhaps Earth was not the center of creation. Galileo's eye pressed to the glass was like the first crack in the shell of an ancient belief. The telescope did not shout or argue, it simply showed. Light spoke for itself, and truth poured through the lens. As telescopes spread, so too did wonder. People gathered to look, to see the blurred smudge of Saturn's rings, the faint mist of star clusters, the delicate threads of the Milky Way broken into countless points of light. The telescope stretched human curiosity across distances that once seemed eternal. Each new observer became both a traveler and a poet, journeying without moving, carried on beams of light that had been traveling for thousands, even millions of years before meeting their eye. To look through a telescope was to gaze into time itself, to receive a message sent long before one's birth. But glass has its limits. A lens can bend light, yet too much bending makes colors bleed into one another. Stars blur, edges shimmer like rainbows. So mirrors entered the story, polished metal surfaces that reflected rather than refracted, gathering light into a clear focus. The reflecting telescope was born, larger and more precise, free from the color-fracturing flaws of lenses. In these mirrors, the sky revealed itself with greater honesty. And as each mirror grew, so too did humanity's reach. Bigger telescopes meant fainter stars became visible, and faint stars gave way to galaxies, each one a congregation of billions of suns. The telescope became a time machine, for the light that enters its lens or mirror is old. The starlight we see tonight may have left its source before pyramids rose, before words were written, before oceans had swallowed forgotten coastlines. When you peer through a telescope, you are not only looking outward, you are looking back, receiving photons that have traveled longer than human history. To hold such ancient light in your eye is to brush against eternity, to feel the immensity of space woven into the fabric of your very perception. And yet the telescope is not just a tool of science, it is an instrument of poetry. It reminds us of our smallness, but also of our capacity to imagine, to question, to reach. To see Saturn's rings is to marvel at the artistry of nature. To see the moons of Jupiter is to witness the symmetry of celestial dance. To see distant galaxies is to feel the humility of being part of a much larger story. Each view through a telescope carries both knowledge and emotion, both measurement and wonder. Imagine standing on a quiet hill, a small telescope resting before you. The air is still, the grass damp with night's breath. Above you, the sky is infinite, but through the narrow circle of the lens, it becomes intimate, almost touchable. The stars no longer feel far away, they press close, whispering their secrets. You linger on the glow of a nebula, a cloud where stars are born. Its delicate swirls of gas shimmer faintly, captured by your lens as though the universe had leaned in to reveal a private truth. In that moment, you are both an ancient dreamer and a modern explorer, carried across centuries by the power of glass and light. The story of telescopes is also the story of patience. Light is faint, and the universe reveals itself slowly to those willing to wait. Astronomers spend long nights adjusting lenses, polishing mirrors, aligning mounts. Their reward is not immediate spectacle, but gradual unveiling. Each faint speck recorded on a photographic plate, each ghostly spiral revealed in exposure, is a gift unwrapped slowly, reverently. The telescope teaches us to slow down, to accept that the grandest truths often arrive as whispers, not shouts. Over centuries, telescopes grew larger, more precise. The observatories rose on mountaintops, far from the haze of cities where the sky was clear and thin. Massive domes rotated gently, their shutters opening like eyelids, allowing the mirrored eyes inside to drink in the night. Within those domes, astronomers became guardians of light, capturing signals that had crossed the gulf of time and space. Each night, humanity's reach extended farther, and as the telescopes grew, so too did our questions. What lies beyond the stars we can see? How many galaxies drift unseen, waiting to be found? Each glimpse was an answer, but also a deeper mystery. The glass that caught the stars was never just glass. It was imagination, molded and curved, given purpose by human longing. Each lens, each mirror, each telescope was a hand reaching into the sky not to possess but to understand. And with every new discovery, the world below was changed. The earth felt smaller, but the human spirit grew larger. To gaze at the stars through glass is to recognize the unity of all things. The same elements that burn in suns also live in our bones. The same forces that shape galaxies also whisper in the atoms of our breath. In seeing outward, we also see inward. And so the telescope remains a symbol, not of conquest, but of curiosity. It is the gentle eye that looks beyond what is near, the fragile lens that gathers the impossible into sight. It teaches us that vision is more than seeing. It is a dialogue with light, a patient listening to the stories carried across space. The glass that caught the stars is still catching them night after night, revealing more, asking us always to wonder, always to dream. The telescope is not only a tool of discovery, it is a bridge of connection. When Galileo raised his glass tube toward the heavens, he connected human eyes to a realm that had been untouched for all of history. But what began with one man's curiosity became a lineage of vision, stretching forward through centuries. Each generation refined the glass, polished the mirrors, and lifted their sight higher. To peer through a telescope is not only to look at the universe, it is to join a conversation with all the dreamers who looked before and all who will look after. The glass holds their echoes, a silent lineage of wonder passed from hand to hand, lens to lens. In the centuries that followed, telescopes became more than personal instruments. They grew into monuments, standing on mountains carved into domes of stone and steel. These observatories were temples of vision, places where light was gathered as faithfully as prayers. Within them, astronomers became guardians of the sky, recording faint glimmers onto photographic plates. A single exposure might last hours, each photon leaving its gentle mark, like raindrops collecting in a bowl. The night air was cold, but the patience of those waiting was warm with purpose. The telescope taught a rhythm slower than heartbeat, slower than breath, the rhythm of stars arriving from across immeasurable time. The eye alone cannot hold so much light. A telescope's mirror acts like a pool, collecting radiance that would otherwise pass unnoticed. Imagine standing before a still lake under the night sky. The stars appear both above and below, their reflections shimmering. The telescope's mirror is much the same. It holds the sky in its polished surface, bending it inward so that eyes may wander through infinity. The deeper the mirror, the more light it can hold, and so the larger the telescope, the fainter the stars it can reveal. In this way, humanity learned that the universe is not a ceiling of scattered jewels, but a boundless ocean filled with galaxies, each galaxy a continent of suns. When William Herschel turned his great reflecting telescope skyward in the late 18th century, he uncovered new worlds that no myth had named. He discovered Uranus, a pale green wanderer drifting in the black. To name a planet was to expand the map of existence, to redraw the very architecture of the solar system. Herschel's telescope did not only add a world, it deepened the mystery of what worlds might still wait, hidden in the shadows. Every new discovery was both a step forward and an invitation. If Uranus was there, what else lay beyond? Herschel also swept the heavens and recorded star clusters, nebulae, and the faint mist of galaxies. His notebooks became atlases of the invisible, catalogs of light too faint for ordinary eyes. In his sketches, you can feel the patience of someone listening closely to the sky, someone who understood that light has stories and telescopes are the vessels that hold them. Each spiral smudge he drew was a mystery that later astronomers would revisit, eventually learning that these nebulae were galaxies far outside our own. Herschel's eye, extended by his telescope, was already walking paths that future generations would confirm with certainty. As telescopes improved, so too did our understanding of distance. For most of human history, the stars seemed painted on a flat dome. They twinkled as equals, all the same distance from Earth. But when astronomers used telescopes to study them more closely, they realized the stars differed not only in brightness but in distance, in size, in age. Some stars were near neighbors, burning only a few light years away, while others had sent their light across hundreds or thousands of years. The telescope became a ruler for the sky, a way to measure what cannot be touched. To gaze into its depths was to see layers of history stacked one upon another, the closer stars shining over the older whispers of light. By the 19th century, telescopes no longer only revealed shapes, they also revealed spectra. When starlight was passed through a prism and then into a telescope, it broke into bands of color, streaked with dark lines. These lines were signatures, fingerprints of atoms and elements. With them, astronomers could tell what stars were made of, how hot they burned, even how fast they moved. A telescope became not just an eye, but an ear listening to the chemistry of the cosmos. The dark gaps in rainbow light spoke of hydrogen, helium, sodium, calcium, elements that also lived within our own bodies. The telescope quietly told us we were not apart from the stars, but made of the same breath and fire. Consider the quiet miracle of this. Glass and mirror, arranged in a careful way, can gather light so faint it has traveled for millions of years, then separate that light into a spectrum, and from that spectrum whisper the identity of atoms older than Earth itself. It is a translation from light to language, from starlight to understanding. The telescope does not speak loudly. It hums in a soft voice, saying, "You and the stars are kin." Yet even as telescopes revealed more, they also reminded us of how much we did not know. With each increase in size and clarity, the universe grew larger. A faint smudge became a galaxy. A cluster of points became thousands of suns. The telescope widened the horizon, but it also moved the horizon farther away. It was like walking toward the edge of the sea, only to find that the water stretched on endlessly. The more we see, the more infinite the cosmos becomes. This is the paradox of telescopes. They satisfy curiosity while deepening wonder, answering questions while multiplying mysteries. Mountaintop observatories rose higher and higher, reaching above clouds, seeking thinner air. On volcanic slopes and desert plateaus, domes opened to the night. Inside, mirrors grew enormous, taller than a person, heavier than stone. These mirrors, perfectly curved, gathered light with the delicacy of a cupped hand. When turned toward a galaxy millions of light years away, they revealed spirals of stars so vast that each spiral could contain countless worlds. The telescope transformed the night sky from a handful of constellations into an immeasurable universe, a universe still unfolding. Imagine an astronomer at such a mountaintop. The night is cold, the wind sharp. The dome above rotates, its shutter sliding open. The great mirror below is polished to perfection, waiting. A switch is pressed and the telescope moves with quiet grace, pointing eye. TS gazed toward a faint patch of sky that looks empty to the naked eye. Hours later, on a photographic plate or digital screen, that empty patch is revealed to be filled with galaxies, hundreds, thousands, like grains of sand poured from an unseen hand. What once looked like nothing is in fact everything. The telescope teaches us again and again that absence often hides abundance. It is easy to think of telescopes as machines, but in truth they are extensions of longing. They exist because humans felt unsatisfied with the visible. They are monuments to questions. When we build a telescope, we are not only constructing a device, we are giving form to desire, giving shape to a dream. To look through one is to step into that dream, to become part of the long chain of seekers who believed the night had more to say, and the night has always had more to say. The telescope also brought humility. For when Hubble, at the dawn of the 20th century, used the Mount Wilson telescope to measure the distance to faint nebulae, he discovered they were galaxies far beyond the Milky Way. The universe was not a single city of stars, but a vast nation of galaxies, each one immense and beautiful. And they were moving, expanding, drifting apart. The telescope told us we were not at the center, not the main stage, but part of a boundless expanse where even our own galaxy is only one among billions. It was a revelation both humbling and exhilarating. The night was far bigger than anyone had dared to imagine. Yet this expansion of knowledge did not erase the intimacy of looking through glass. Even as the cosmos grew vast, the act of observing remained personal. A single person, alone in the dark, looking through an eyepiece, could still feel a bond with the stars. The telescope carried both scales at once, the immensity of galaxies and the closeness of light touching the eye. It allowed humans to live in two worlds, the infinite and the immediate, without contradiction. The glass that caught the stars has always been more than technology. It is a poem written in light, recited slowly across centuries. Each improvement, each larger mirror, is another stanza added to that poem. And we, who listen through these instruments, are both readers and authors, shaping our place in the cosmic story. For every new discovery, whether a planet, a star, a galaxy, is not just a fact. It is a verse, reminding us that the universe is written in light, and telescopes are the instruments that let us read it. The telescope story is not one of sudden leaps, but of gentle widening, like ripples spreading across water. Each generation has taken the light gathered by earlier hands and reached a little farther. What began with a small glass tube in Galileo's time grew into great domes of silver and steel, and from there it drifted beyond Earth itself, into the silence of space. To follow this journey is to see how curiosity takes root in simple beginnings and blooms into wonders that reshape our sense of existence. The telescope is no longer only an object we carry to mountaintops. It is a companion we send into the cosmos itself, where the air is thin and the sky never closes. When the Hubble Space Telescope opened its eye above Earth in 1990, The universe itself seemed to lean closer. Free from the trembling blur of atmosphere, Hubble's mirror drank starlight with clarity no ground telescope could match. Its images spilled across the world. Newborn stars swaddled in clouds of gas, galaxies tangled in slow collisions. The faint red glow of light stretched thin across billions of years. Hubble was not just a machine. It was a window, clear and endless, through which humanity saw itself anew. For when we saw galaxies receding into the dark, we understood that the universe was not static, but alive with expansion, still stretching from an ancient beginning. One of Hubble's most powerful gifts was the deep field. Astronomers pointed it at a patch of sky so small it seemed empty, no larger than a grain of sand held at arm's length. For days, Hubble gathered the faint light, and when the image was revealed, it was not empty at all. It was filled with galaxies, thousands upon thousands, each one a universe of stars. The emptiness was an illusion. The cosmos was crowded with abundance, and what we thought was nothing turned out to be everything. That image, the deep field, is perhaps one of the most profound reminders ever captured. The sky is never bare, only waiting to be seen. The telescope's gaze also reached backward in time, to light so ancient it carried whispers of the universe's birth. By studying faint afterglows and redshifted light, astronomers pieced together a story older than stars, the story of the Big Bang, of space itself unfolding from a point of fire. To imagine such beginnings is dizzying, yet the telescope renders it calm, as though the universe has always been telling us its story, waiting for us to learn the language of light. In the quiet patience of telescopes, we began to hear echoes of creation itself. Beyond Hubble, new eyes were born. Radio telescopes, with their sweeping dishes spread across deserts, captured whispers invisible to ordinary eyes. They listened to the universe not in light, but in waves of soundless radio, revealing pulsars ticking like cosmic clocks, galaxies shining in frequencies no human had ever known. Where glass and mirror showed us brightness, radio telescopes revealed rhythm, the heartbeat of the cosmos echoing across space. Together they wove a fuller song, light and wave, brightness and pulse, all part of a single symphony. And now the James Webb Space Telescope has opened yet another chapter. With its golden mirrors folded like a flower, it bloomed far beyond the moon, in the stillness of space where Earth's warmth cannot blur its vision. Webb's gaze is tuned to the deep infrared, allowing it to see through veils of dust, to witness stars being born, to catch the glow of galaxies that formed soon after the beginning of time. Its images are not only data, they are portraits of creation, painted with light older than the Earth itself. In each photograph lies a paradox. They show us something utterly new, yet also something unimaginably ancient. Telescopes now do more than show us beauty. They help us ask whether we are alone. With them, astronomers study distant planets orbiting other stars. By splitting their light, they search for signs of water, oxygen, carbon, elements that might whisper of life. To think that a telescope, a mirror of glass and gold, can detect the breath of worlds we cannot visit is to realize how finely tuned our instruments have become. They do not merely extend sight, they extend hope, allowing us to dream of neighbors scattered among the stars. Yet in all this, the telescope still carries its original spirit, the blending of science and poetry. When you stand before one, whether a small telescope on a hill or a great observatory, you feel not only the hunger for knowledge, but also the sweetness of wonder. The telescope invites you to lean close, to look through its eye, and to become a child again beneath the sky. It reminds you that the universe is both vast and intimate, both eternal and fleeting. In its glass, you see not only distant galaxies, but your own reflection, small yet luminous, a piece of starlight looking back at the stars. The telescope also teaches humility. The more we see, the more we know how much remains unseen. No telescope, no matter how vast, can capture the entire cosmos. There will always be light too faint, distances too great, mysteries too deep. And yet this limitation is not despair, it is invitation. The unfinished sky asks us to keep wondering, to keep building, to keep dreaming. The telescope is not the end of vision, but the beginning of an endless pursuit, a reminder that curiosity itself is infinite. As the story of telescopes continues, we can imagine futures where mirrors float larger than cities, where arrays of instruments stretch across the moon's dark plains, where probes carry telescopes to the edge of our solar system and beyond. These are not fantasies, but seeds already being planted. Humanity's eyes will only grow clearer, its reach only deeper. And with each step, the night will unfold a little more, like a scroll of ancient writing slowly revealed. But even now, in this very moment, the telescope offers its quiet gift. On any clear night somewhere, someone raises a small telescope to the sky. The instrument may not be mighty, but the act is sacred. A child looks at Jupiter's moons and feels the same wonder Galileo felt. A curious soul lingers on Saturn's rings and realizes the universe is more intricate than they imagined. A quiet heart gazes at a nebula and senses the birth of stars, the same process that once gave birth to the atoms in their own body. The telescope is not just a machine for the few, it is a companion for anyone who longs to listen to the sky. And so the glass that caught the stars continues to catch them. It gathers light across centuries, across distances too great to fathom, across silence too deep to measure. It takes what is faint and makes it clear, takes what is far and makes it near. In its lens, we find not only galaxies and planets, but also reflections of ourselves, fragile, curious, luminous beings made from the very elements we seek. The telescope whispers softly, "You belong to this universe." You are not separate from the stars you watch. You are a spark of their ancient fire, gazing back through the glass, remembering your origin. Perhaps that is the truest gift of the telescope. Not the catalogs, not the measurements, not even the breathtaking images. Its greatest gift is perspective. To look through a telescope is to feel both small and vast at once, humbled by immensity, yet uplifted by connection. It shows us that wonder is endless and that light, no matter how far it has traveled, ways finds its way into an eye willing to see. The telescope teaches us to be patient, to listen, to imagine. It tells us gently that the universe is not silent. It has been singing all along, and through the glass we are finally learning to hear. A mirror is a simple thing, a surface polished until it gives back what it receives. Yet in the story of telescopes, mirrors are more than reflections. They are vessels of time and light. To look into a mirror is to see yourself returned, but to look through a telescope's mirror is to see the universe as it once was, light carried across centuries, millennia, even billions of years. The mirror does not just return, it gathers, it bends, it reveals. In its curve lies the quiet alchemy of vision, the power to collect the faintest whispers of the cosmos and shape them into clarity. The earliest telescopes bent light with glass, refracting it through lenses. But lenses, though powerful, fractured color, bending some hues more sharply than others. Stars blurred at the edges, rainbow halos clung to their forms. The search for clearer sight led to mirrors. A mirror, polished with patience, does not separate light into colors. It bends them all together, drawing every wavelength to the same focus. What emerges is sharper, truer, a portrait of the sky without distortion. Thus began the age of reflecting telescopes, where metal and glass became the eyes of humanity. Isaac Newton was among the first to shape this vision. He built a small reflector, its mirror made of polished metal. Though modest in size, it proved that mirrors could pierce the heavens with clarity lenses could not. This little instrument carried with it a revolution. From then on, mirrors would grow larger and larger, spreading out into wide circles that caught ever more light. Each increase in size was like widening the pupil of a cosmic eye, allowing humanity to see fainter, deeper, older light. Through mirrors, the sky became a history book, each star and galaxy a chapter written in photons. Light is time made visible. When you gaze into the mirror of a great telescope, you are not seeing the universe as it is now, but as it was when the light began its journey. A star 1,000 light-years away shines into your eye with light that left before a single human word was written. A galaxy 100 million light-years away reveals itself as it was when dinosaurs roamed Earth. The farther the mirror gathers, the deeper into time it reaches. Each reflection is a memory, a fragment of the past preserved in the present. To look into a telescope's mirror is to peer into time itself. This is why mirrors matter. A lens bends light, but a mirror holds it, embraces it, brings it gently together. And in that gathering, we are allowed to witness what would otherwise remain unseen. Consider the great mirrors mounted high on mountains, the Hale telescope at Palomar, the Keck twins in Hawaii, the Very Large Telescope in Chile. Each one is a polished pool of light, a human-made lake that gathers the stars. Astronomers stand beside them like keepers of a sacred flame, watching as light, older than memory, pools into the glass, forming images that expand the boundaries of human thought. The engineering of these mirrors is itself a wonder. They must be ground and polished with precision so fine that even the smallest imperfection would scatter light into confusion. Their curves are shaped to fractions of a wavelength, smoother than any stone, more exact than any jewel. Held within these shapes is not only science but devotion, for crafting a mirror is an act of faith, that light will come, that the sky will answer, that patience will be rewarded with revelation. Every groove polished away is a promise kept, a commitment to clarity. As mirrors grew, so too did their power. The great 200-inch mirror at Palomar, completed in the mid-20th century, became a milestone, capturing light from galaxies beyond imagination. Through its eye, astronomers saw quasars, brilliant beacons blazing at the edge of the visible universe. They studied the swirling hearts of galaxies, the dance of stars around invisible centers of gravity, hints of black holes long before their reality was confirmed. The mirror at Palomar was more than glass and metal. It was a key, opening doors into realms no one had entered before. Later came the Keck telescopes, with mirrors made not of one solid piece, but of many hexagonal segments fitted together. Like a mosaic of light, these pieces formed a whole larger than any single mirror could be. This design allowed mirrors to grow vast without cracking under their own weight. The segmented mirror became a symbol of cooperation, each piece alone insufficient, but together, a perfect surface for gathering the cosmos. In this way, the telescope became not just a tool, but a metaphor. Just as mirrors join to form one eye, so too does humanity join, each mind adding to the vision of the whole. But mirrors did not stop at Earth's surface. They rode on rockets, folded like petals waiting to bloom in space. The Hubble Space Telescope's mirror was not large compared to ground giants, but it had the advantage of clarity above the blur of atmosphere. And when the James Webb Space Telescope unfolded its golden hexagons, it carried mirrors into a realm untouched by earthly air, where silence and cold allowed them to see deeper than ever before. These mirrors now gather light that has traveled for billions of years, light from the first galaxies, light from the dawn of time. They are not only instruments, they are messengers, bringing us word from epochs when the universe was young. The mirror is a paradox. It shows us ourselves, yet also what lies beyond. In the polished circle of a telescope's heart, the universe and the observer meet. You lean over the eyepiece, and your reflection mingles with starlight billions of years old. The glass holds both the immediacy of your breath and the eternity of galaxies. It reminds us that we are not separate from the universe, but part of it, reflections within reflections, light observing light. Imagine standing beside a great mirror on a mountain. The night is still, the dome above sliding open with a hushed sound. Stars spill overhead, sharp and countless. Within the observatory, the mirror tilts, finding its place. The operator adjusts controls, the telescope shifts, and suddenly the mirror is drinking the glow of a galaxy so faint it cannot be seen with human eyes alone. Hours pass and the mirror gathers, patient as stone, holding every photon until the image sharpens. On the monitor, a spiral emerges, delicate arms curling outward, dust lanes weaving across its heart. You are seeing a dance that began before Earth was born, revealed now because a mirror reached into the dark and held the light. The story of mirrors is also the story of ambition. Each generation asks, how much farther can we see? How much older can the light be that we gather? And so mirrors expand. Plans are already underway for mirrors 30, 40 meters wide, vast eyes that will drink starlight more deeply than ever before. These telescopes will reveal planets around distant stars with clarity enough to study their atmospheres to search for signs of life. They will trace the earliest galaxies, uncovering structures that formed when the universe was still in its infancy. They will show us not only where we are, but where we came from, and perhaps even where we are going. Yet for all their size and complexity, mirrors still carry the same quiet poetry as the first polished surfaces of ancient times. To polish a mirror is to honor light. To look into a telescope is to accept an invitation written across the night sky. Mirrors remind us that the universe is not closed, not complete, but open and unfolding. They remind us that every photon, no matter how faint, carries a story. And they remind us that we too are mirrors, our eyes, our minds, our hearts, reflecting the cosmos back to itself. In the end, mirrors of time and light are not only tools of science but companions of wonder. They catch what is fleeting and make it endure. They gather whispers from the deep and bring them close. They reflect not only stars but dreams, not only galaxies but questions. And in their silent curves, they remind us of the simplest truth. The universe is here, waiting to be seen, waiting to be known, waiting to be remembered. We need only hold up a mirror and let the light come home. Every mirror, no matter how vast, begins as an idea. At first, it exists only in the imagination of astronomers and engineers who wonder what more might be seen if light could be gathered more fully. They sketch designs, whispering of diameters greater than before, of surfaces smoothed to impossible precision. Then come the artisans, the builders, the polishers. They shape the raw glass or assemble the segments, layer upon layer, until a mirror emerges that can cradle the stars. To build a telescope mirror is to build trust in light itself, to believe that the sky will reward patience with revelation. Each curve polished is a question posed to the universe, and each photon gathered is an answer given. Mirrors are not only surfaces of reflection, they are keepers of silence. When you stand inside an observatory at night, the mirror rests quietly in its frame, dark until starlight touches it. Then slowly, faint glimmers appear, as though the sky has bent down to leave its secrets upon the glass. To gaze at such a mirror in the dark is to see the cosmos arriving in real time, gently settling into the circle of polished surface. You feel the presence of time, ancient and immediate all at once, a weightless cascade of memory flowing onto the glass. The mirror is a lake in which the past drifts back into the present. Consider the Hale telescope at Palomar. For decades, its 200-inch mirror was the largest in the world, a disk of glass heavier thaw. And mountains of thought. Yet when astronomers stood at its eyepiece, what they felt was not heaviness but lightness, as galaxies bloomed on photographic plates, as quasars flashed their distant brilliance, as black holes whispered their presence through the dance of stars. The mirror gathered light not just for images but for truths, proof that the universe was stranger and more dynamic than ever imagined. In the quiet of Palomar's dome, mirrors became storytellers, reciting verses in the language of starlight. As time moved on, telescopes multiplied and spread across the globe. In Chile's Atacama Desert, where air is dry and skies are clear, mirrors stare endlessly into the night. There, the Very Large Telescope, a name both humble and profound, uses its segmented mirrors to study stars, galaxies, and planets with astonishing precision. When its mirrors work together in unison, their power multiplies, creating an eye that can resolve details finer than any single mirror alone. In this cooperation of reflections lies a lesson. The universe yields more when eyes are joined, when vision is shared. Segmentation itself is a miracle of modern mirrors. A solid mirror has limits. It grows too heavy, too fragile, too cumbersome. But a segmented mirror made of smaller hexagons can expand almost without bound. Each piece must be aligned with exquisite precision, adjusted so finely that they behave as one continuous surface. It is an orchestration of light, each segment playing its note in harmony. When you stand before such a mirror, you see not one polished surface but many, united in purpose. It is a reflection of human unity, a reminder that great visions require many hands, many hearts, many minds. Light that falls onto a mirror is more than brightness, it is information. By gathering it, mirrors extend our senses beyond anything the human eye could achieve. With spectroscopy, the mirror channels starlight through prisms and detectors, revealing the fingerprints of elements, the tug of gravity, the stretching of expansion. Every dark line, every shifted color is a message. A star's composition, a galaxy's motion, a planet's air, all these truths travel across space and time, only to come to rest upon a mirror before entering the mind of a patient observer. The mirror does not only reflect the universe, it translates it into meaning. But mirrors also confront us with scale. They show us that the universe is not only immense in space but in time. When light takes millions or billions of years to arrive, the images captured are fossils of light, snapshots of an earlier universe. Each galaxy seen is a memory of itself, a relic from when its stars were younger, when its arms curled tighter, when its black holes were smaller. The mirror teaches us that we are never seeing the universe as it is, we are always seeing it as it was. This is not deception, but intimacy. The mirror allows us to touch what is long gone, to hold in our vision something older than our entire species. Imagine peering into a mirror aimed at a quasar, a beacon shining from the far edge of the cosmos. Its light left billions of years ago, traveling ceaselessly until at last it strikes the polished surface. The photons that now touch your eye began their journey before Earth had continents as we know them, before mammals walked, before oceans teemed with familiar life. To see them is to bridge epochs, to fold time into a single moment of vision. The mirror is not just a surface, it is a time machine, carrying us into histories unreachable by any other path. The greatest mirrors are not alone, they work together across continents. Radio telescopes spread thousands of kilometers apart combine their reflections, creating virtual mirrors the size of Earth itself. Through this technique, astronomers captured the first image of a black hole's shadow, a ring of light around darkness at the center of a galaxy. That image, faint and blurry yet profound, was a triumph of mirrors, not of a single piece of glass, but of many instruments acting as one, stretching human sight across the globe. Here again, mirrors show their dual nature, solitary in function, communal in spirit. It is easy to imagine mirrors as cold, mechanical things. Yet when you stand beside one, especially under the night sky, you feel warmth. You see your own reflection in the glass, mingled with stars. You realize that the mirror holds not only the universe, but you as well. You are part of the image, part of the reflection, inseparable from what you observe. This quiet truth has echoed through centuries, that to study the stars is also to study ourselves. The mirror shows us the cosmos, but it also shows us our place within it, small yet luminous, fleeting yet connected. The future of mirrors is already unfolding. Plans for the extremely large telescope in Chile promise a mirror nearly 40 meters across, a vast surface that will gather light as no eye has ever done. Its vision will be sharp enough to study the atmospheres of exoplanets, to search for chemical hints of life. It will peer so far into the universe that it may capture galaxies formed at the dawn of time. When it opens its eye, it will not just extend science. It will extend imagination, reminding us that the mirror is never finished, that there will always be more light to gather, more time to reflect, more stories to unfold. But even as we dream of the future, we must remember the present. Tonight somewhere a mirror is already catching light. It may be a giant telescope on a mountaintop or a small backyard reflector turned toward the moon. Both are sacred, both are acts of wonder. Whether grand or humble, each mirror does the same work. It accepts what the sky offers and it gives it back with clarity. The universe asks only that we look, and the mirror answers by showing us what we seek. In this partnership of cosmos and reflection, we find not just knowledge but meaning. In the stillness of an observatory, you can almost hear it. The quiet hum of motors, the faint creak of gears, the whisper of wind outside. And in the center, the mirror, silent, waiting. Then, as light begins to fall, as photons land upon its polished surface, a kind of music begins. It is not sound, but rhythm, the steady arrival of ancient light, one particle after another, gathering into form. That music is the heartbeat of the universe, audible only through patience, visible only through mirrors. To witness it is to be drawn into the slow poetry of existence, where every moment is filled with echoes of eternity. And so mirrors continue their work, reflecting not only light but time, not only stars but wonder. They are the still waters in which the cosmos gazes at itself, and we, leaning close, become part of that reflection. In their silence lies a lesson, that to see is not only to receive, but also to give back, to hold what is fleeting and to let it linger. The mirror does not keep the light for itself, it shares it freely, endlessly, with anyone willing to look. And in that sharing, the universe becomes intimate, a story whispered gently into our eyes. The story of mirrors is a story of persistence, a patient unfolding of vision across centuries. From polished metal that tarnished in the damp air of Newton's time, to gleaming discs of glass on mountaintops, to segmented hexagons unfolding like petals in space, mirrors have carried our gaze farther and farther. Each one represents a promise kept, that human curiosity will never be satisfied with limits, that we will always shape surfaces to catch what lies beyond reach. The telescope's mirror is not only a scientific tool, it is a mirror of human spirit, shaped by longing as much as by technology. When you lean close to a mirror in a telescope, what you see is not the surface itself, but the sky it gathers. Yet hidden in that reflection, there is always a trace of yourself as well. The stars shine, the galaxies drift into view, and faintly in the black polish your own outline lingers. You are reminded that observation is never one-sided. The cosmos looks back through the same light you receive. We are participants in the exchange, not distant spectators. Mirrors of time and light make this truth visible. We are woven into the very fabric we study, both subject and observer, both reflection and source. As mirrors grew more perfect, they uncovered truths that reshaped our understanding of the universe. They showed us that galaxies are not static islands, but dynamic systems, swirling with spiral arms, colliding, merging, evolving across billions of years. They revealed black holes, invisible yet undeniable, their presence traced by the dance of stars caught in their gravity. They captured supernovae, brilliant deaths of stars scattering elements into space, the same elements that build our bodies and breath. Every mirror brought us closer to seeing that the universe is alive with cycles, creation, transformation, dissolution, all mirrored in our own lives. In this way, the telescope did not only expand astronomy, it deepened philosophy. In recent decades, mirrors have grown collaborative. Adaptive optics systems, mounted on large telescopes, bend and shift tiny portions of the mirror in real time to correct the blur of Earth's atmosphere. Thousands of subtle adjustments every second keep the starlight sharp, as though the mirror were alive, breathing with the sky. This technology has turned mountaintop observatories into near-space instruments, capable of resolving details once thought impossible from Earth. It is a marriage of ancient patience with modern precision, the mirror transformed from a passive surface into an active partner in seeing. And through this partnership, the stars themselves seem closer, sharper, more intimate than ever before. The journey of mirrors also carries a lesson about fragility. Mirrors are sensitive, vulnerable to dust, to scratches, to even the lightest touch of a careless hand. They must be cleaned with care, maintained with devotion, guarded like treasures. Yet despite their fragility, they endure. Some mirrors have gathered light for generations, reflecting the cosmos to eyes that have long since closed. The Palomar mirror has shown its images to astronomers young and old, to dreamers who came and went, while it remained steadfast, drinking starlight each night. There is poetry in this endurance. Fragile as they are, mirrors hold time more faithfully than we do, offering continuity across human lifetimes. Beyond science, mirrors have inspired art, philosophy, and imagination. Writers and poets often compare the human soul to a mirror, reflecting what it encounters, catching fleeting impressions of life. The telescope's mirror extends this metaphor into the cosmic. It reflects not only what surrounds us, but what surrounds all things. It shows that we are part of something immeasurably vast, yet it also shows that vastness is not cold but luminous, filled with stories written in light. To gaze into such a mirror is to feel a kinship with the universe, a gentle recognition that we are not apart but within. Imagine again a night at an observatory. The dome opens, the telescope moves into position. The mirror waits in darkness until the first photons fall. Slowly the image builds, and what emerges is a galaxy billions of light years away. Its light began when Earth was a young planet, when oceans were still forming, when no eyes existed to dream of stars. Now, across unthinkable time, those photons are caught in a mirror and guided into your sight. You are the first creature in history to witness them. That intimacy is almost unbearable, yet also tender. It is the quiet gift of mirrors. They bring the ancient into the present, allowing us to hold eternity for a moment in our eyes. The future of mirrors stretches far ahead. Concepts exist for orbiting mirrors, many kilometers wide, delicate films of reflective material stretched in space like sails. These would catch light too faint for any solid mirror, mapping the earliest galaxies, the first stars, the formation of cosmic structures. Other visions place mirrors on the far side of the moon, shielded from Earth's noise, staring forever into the untouched sky. These ideas are bold, but they follow the same humble principle as Newton's small reflector. Polish a surface, hold it steady, and let light tell its story. The essence of mirrors remains unchanged, even as their scale grows beyond imagination. Perhaps the most moving thought is that mirrors of time and light are not confined to observatories. They exist within us as well. Our eyes are small mirrors, our memories reflect moments long gone, our hearts reflect the connections we make. Just as a telescope's mirror gathers starlight, we gather experiences, and both reveal truths about the universe. The telescope may be made of glass and metal, but the longing that built it is the same longing that shapes human lives. The desire to see more, to understand more, to be connected to something greater. In this sense, the mirror is not only outside us, but within us, polished by wonder. And so the story closes softly. The mirrors of time and light remain, standing on mountains, drifting in space, waiting in backyards, always gathering what the universe offers. They are lakes of clarity, oceans of patience, surfaces that catch what is otherwise invisible. Through them, we see the universe not as an abstract void, but as a living story, luminous with meaning. We see ourselves reflected in the stars, and the stars reflected in us. And as long as mirrors are lifted to the sky, that story will continue, endlessly unfolding, one reflection at a time. The universe speaks in more than light. Beyond the glow of stars and the shimmer of galaxies lies another voice, one that cannot be seen with ordinary eyes. It hums in long, invisible waves, low and patient, stretching across space like ripples in a boundless ocean. This is the radio sky, a realm of whispers too faint for the human ear, too wide for the human eye, yet filled with stories that light alone cannot tell. When we built instruments to listen, we discovered that the universe was not silent at all. It was singing softly in frequencies hidden beneath the veil of night. The first to hear these whispers was not an astronomer, but an engineer. Carl Jansky in the 1930s was building radio equipment to study static for telephones. One day he noticed a strange signal, steady and repeating, that rose and fell with the turning of the earth. It was not noise from storms, nor interference from machines. It was coming from the sky, from the very center of our Milky Way. In that moment, a door opened. The universe was not only shining, it was broadcasting. For billions of years, it had been humming, waiting for us to notice. With that discovery, radio astronomy was born, and the night became not only a canvas of light, but a symphony of waves. Radio telescopes are unlike their glass-eyed cousins. They are vast dishes, curved and white, some so large they fill entire valleys. Their surfaces do not need to be as perfect as a mirror for visible light, because radio waves are long, forgiving. Instead, the dish gathers them, reflects them toward a receiver, and transforms the whispers into signals that can be understood. These signals, though invisible, carry the same truth as starlight. They reveal where stars are born, where gas drifts, where galaxies collide. They map the universe in a language more subtle, a language of hums and pulses rather than brightness and color. Imagine standing beside such a dish at night. The stars above are bright, but the dish points into the darkness with patient silence, waiting. You hear only the wind and perhaps the faint creak of metal, but within the receiver, the universe is speaking. A pulsar, thousands of light years away, ticks steadily, each pulse a rotation of a collapsed star, spinning like a cosmic lighthouse. Quasars, billions of light years distant, beam energy brighter than galaxies, their signals faint but insistent, arriving after journeys across unimaginable spans of time. To listen to them is to lean close to the cosmos, to place your ear against infinity. Radio telescopes expanded our vision in unexpected ways. They revealed the structure of the Milky Way, its spiral arms traced by the faint glow of hydrogen gas. They showed that galaxies were not only glowing islands of stars, but also reservoirs of invisible matter, spinning too fast to be explained by what we could see. From these whispers came the first hints of dark matter, the unseen fabric shaping the universe. Radio waves told us that what we see is only part of the story, that the cosmos holds more than eyes alone can ever grasp. Through radio astronomy, the universe became layered, rich, filled with hidden dimensions of truth. The most astonishing discovery came with pulsars. In 1967, Jocelyn Bell, a graduate student, noticed a strange, regular signal in her data, a pulse repeating every second. At first, it was so steady she wondered if it might be artificial. She even nicknamed it LGM for Little Green Men. But soon it became clear. These were the signals of neutron stars, the collapsed remnants of massive suns, spinning with incredible speed. Each pulse was a heartbeat of the cosmos, a clock so precise it rivaled atomic timekeepers. Through the radio sky, we heard the voices of dead stars, still speaking long after their deaths, their signals crossing space like messages from ghosts. Then came quasars, discovered in the 1960s. Their radio signals were strange, their optical counterparts faint. For years, astronomers puzzled over what they were until it became clear. Quasars were the blazing hearts of galaxies, powered by supermassive black holes consuming matter and releasing unimaginable energy. Their whispers reached us from the edge of the observable universe, announcing that even in the most distant corners, the cosmos burned with activity. Quasars showed us that black holes were not silent voids, but engines of power, capable of shaping galaxies themselves. All of this was revealed not by visible light, but by radio waves, soft and unseen. Radio telescopes also taught us to collaborate across distance. A single dish can listen, but when many dishes spread across Earth work together, their combined signals create a virtual telescope as large as the space between them. This technique, called interferometry, has given us our sharpest vision of the universe. With it, astronomers mapped the gas clouds of galaxies, traced the jets of quasars, and even captured the shadow of a black hole. The Event Horizon Telescope, a network of dishes spanning the globe, turned Earth itself into one vast ear pressed against the universe. And in doing so, it revealed the first image of a black hole's edge, a ring of fire encircling silence. The radio sky is not static, it is alive with transients. Bursts of energy flare and fade, lasting only milliseconds but carrying the power of suns. These fast radio bursts, first discovered in 2007, remain a mystery. They may come from magnetars, the most magnetic stars in existence, or from other exotic sources yet unknown. They arrive unannounced, sudden and fleeting, but radio telescopes catch them, record them, and remind us that the cosmos is full of surprises. Even now, the sky still holds secrets, whispering in ways we are only beginning to hear. To listen to the radio sky is to shift perspective. Visible light paints the universe in brilliance, in colors and shapes that stir the eye. But radio waves tell a quieter story, one of hidden structures, faint rhythms, and steady pulses. They remind us that the universe is not only seen but also heard. It is not only an image but a song. And in that song we find patterns that connect us to forces far beyond ourselves. Each wave is a bridge, each signal a thread, weaving us into the vast tapestry of existence. Perhaps the most humbling truth is this: Earth itself glows in radio waves. Our planet, wrapped in an atmosphere and magnetic field, hums gently into space. The auroras that dance at the poles release their own whispers, carried outward into the dark. In this sense, we are not only listeners, we are participants. Our technology, our broadcasts, our very presence adds a faint, artificial voice to the cosmic choir. Somewhere far away, another civilization with its own radio ears might hear us, might detect the echo of our existence, faint but undeniable. The radio sky is not only a window outward, it is also a mirror, reflecting ourselves into the cosmos. And so the whispers of the radio sky continue. Night after night, dishes turn and listen, their silence filled with meaning. The signals they catch are faint, but their stories are immense. They tell of galaxies in motion, of stars collapsed into pulses, of black holes blazing, of mysteries yet unsolved. To hear them is to be reminded that the universe is alive, restless, and full of voice. The radio sky hums with eternity, and we, patient listeners, are learning to understand its song. To listen to the radio sky is to realize that the universe has voices layered upon voices, each speaking in a different rhythm, each carrying a different memory. Where the eye sees brilliance and shape, the radio ear hears depth and persistence. The cosmos does not send its stories in one tongue, it offers them in many, and radio waves are among its most patient languages. Long after visible light has faded, radio signals continue their journey, crossing the gulfs of time and space until they fall upon a dish of metal on Earth, waiting in silence. One of the most profound truths revealed by radio telescopes is that hydrogen, the simplest and most abundant element, speaks clearly across the void. At a wavelength of 21 centimeters, neutral hydrogen emits a faint signal, one that is invisible to our eyes but steady in radio waves. By listening to this single whisper, astronomers have mapped the spiral arms of the Milky Way, traced the motion of gas within galaxies, and uncovered the presence of vast clouds of matter between stars. This one frequency has become a thread binding us to the skeleton of the universe, showing us that even the most common atom carries messages written in wave and rhythm. Hydrogen's whisper also revealed that galaxies spin faster than expected. When astronomers measured their rotation, they found that the stars at their edges moved with surprising speed, as though pulled by an unseen hand. The visible matter, the stars, the gas, was not enough to account for this motion. Something invisible was holding galaxies together, something massive yet undetectable except through gravity's pull. Thus, through the quiet language of radio, the first clear evidence of dark matter appeared. The universe was not only luminous but shadowed, not only what we could see, but also what we could not. Radio waves reminded us that much of reality lies beyond vision, waiting to be sensed in other ways. The radio sky also told us about the birthplaces of stars. Within great nebulae, gas gathers, collapses, and ignites into new suns. These nurseries are often hidden behind veils of dust, opaque to visible light, but radio waves slip through, revealing the shapes of clouds, the chemistry of their gases, the rhythms of their collapse. To listen to such regions is to hear the lullabies of creation, the hum of stars preparing to shine. It is a reminder that silence is never empty. It is often filled with beginnings too subtle for ordinary senses. Radio telescopes showed us that galaxies are not isolated islands, but part of a web, connected by filaments of gas stretching across cosmic distances. These structures, faint and sprawling, are invisible in optical light, yet they sing in radio waves. The cosmic web, the grand architecture of the universe, became visible not through eyes but through ears. To map it is to trace the invisible strings upon which galaxies are hung, a vast network of matter weaving space into a tapestry too immense to comprehend fully. The whispers of the radio sky are not random, they form patterns, harmonies that reveal the shape of existence itself. The human relationship with the radio sky deepened when we began to send our own signals outward. For more than a century, Earth has been leaking radio waves into space, broadcasts of music, voices, messages, and noise. These signals travel outward in expanding spheres, reaching farther with each passing year. Though they grow faint with distance, they carry with them the trace of our presence, the echo of our lives. Somewhere far away, our planet glows softly as another star might glow, but in radio rather than light. If there are listeners, they may already have heard us, faint but undeniable, a young civilization adding it. Less note to the cosmic choir. But perhaps the most haunting whispers are those of pulsars. These collapsed stars, spinning with unimaginable speed, send beams of radio waves sweeping across the sky. Each rotation creates a pulse, regular and precise like a cosmic clock. Some spin once a second, others hundreds of times per second. Their stability is so great that they rival the accuracy of atomic clocks, keeping time across millions of years. To hear them is to hear the heartbeat of the universe, steady and sure, a rhythm that will outlast entire civilizations. These pulses remind us that even in death, stars continue to give, their collapsed forms broadcasting messages across eternity. Quasars too sing in radio waves, though their song is different. They are the blazing hearts of galaxies, powered by black holes that consume matter and release energy across the spectrum. In radio, they are among the brightest sources, beacons visible from billions of light years away. To catch their signals is to hear a story from the early universe, a time when galaxies were young and restless. Each whisper is an echo of immense power, of creation and destruction intertwined. Quasars remind us that the universe is not only quiet and patient, but also fierce and wild, alive with forces beyond measure. The discovery of fast radio bursts added yet another verse to the song of the cosmos. These flashes, lasting only milliseconds, are brighter than entire galaxies in that brief moment. Their origins remain uncertain, perhaps magnetars, perhaps phenomena yet unknown. They arrive without warning, sudden and brief, like cosmic knocks on the door of awareness. To detect them requires vigilance, patience, and the willingness to accept surprise. They remind us that the universe is not fully charted, that there are still secrets, still mysteries, still voices we have not yet recognized. The radio sky is not finished speaking. To imagine the scale of listening is humbling. Radio telescopes like Arecibo, before its collapse, stretched across valleys, their dishes wider than stadiums. The Green Bank Telescope rises like a giant's ear in the mountains of West Virginia. Arrays like the Very Large Array in New Mexico spread across the desert like a field of white flowers, each dish turning in unison to follow the sky. Together, these instruments listen day and night, their silence filled with meaning. They remind us that hearing the universe requires patience, persistence, and reverence. The whispers they catch are faint, but in them lie the grandest truths. And yet, for all their size and power, the essence of radio telescopes remains simple: to gather what the universe offers and to share it. They are ears pressed to the sky, patient listeners who never interrupt, who never demand, who simply wait. In their silence lies a lesson for us, that listening is itself a form of wisdom. The radio sky teaches us that not all truths come in brilliance and spectacle. Many arrive in whispers, subtle and quiet, waiting for us to notice. To hear them is to practice humility, to accept that the universe speaks in many voices, not all of them loud. The poetry of the radio sky is that it reveals both the immense and the intimate. It shows us galaxies colliding, black holes blazing, and stars collapsing. Yet it also shows us hydrogen atoms spinning, gas clouds drifting, faint rhythms too small to see but vast enough to shape entire galaxies. It is a reminder that scale is an illusion, that the smallest whispers can reveal the largest truths. To listen to the radio sky is to learn that wonder does not depend on brightness, but on presence. Even the faintest signal carries meaning, if only we are patient enough to hear it. In this way, the radio sky has expanded our sense of belonging. We are not only creatures of light, but also creatures of soundless rhythm, of signals and echoes, of whispers that tie us to the cosmos. The universe hums and we hum with it. To place our ears against the sky is to remember that we are part of the same song, written in waves that cross space without tiring. The radio sky is not foreign, it is familiar, calling us gently to listen, to pause, to hear the music that has always been playing. The whispers of the radio sky remind us that silence is never truly empty. Even when the night feels still, the air above our heads is alive with waves, long, invisible currents that pass through us without notice, carrying the stories of stars and galaxies. To tune into them is to realize that we are surrounded by messages, not in words but in frequencies, not in sound but in rhythm. These waves do not fade with distance. They persist, stretching across billions of light years, threads of memory woven into space itself. The radio sky is not quiet, it is patient, waiting for ears willing to listen. When we listen carefully, we find that the radio sky holds the beginnings of time itself, the faint afterglow of the Big Bang called the cos. Microwave background hums across the universe. It is a radio whisper from when the cosmos was only 380,000 years old, when atoms first formed and light was free to travel. This background fills every corner of the sky, uniform yet speckled with tiny variations that seeded galaxies and stars. To detect it is to hear the birth cry of the universe, a soundless murmur that has echoed for nearly 14 billion years. No other message is so ancient, no other whisper so enduring. In this quiet, we hear our origins. The cosmic microwave background is not loud, but it is everywhere. It washes over the earth through us, through the dishes of radio telescopes as constant as breath. To listen to it is to hear the first heartbeat of creation, a rhythm that has never stopped. Every other signal, pulsars, quasars, hydrogen bursts, rests upon this deeper foundation. The radio sky tells us that the universe was not born in silence, but in a chorus of waves still unfolding. When we turn our instruments toward the heavens, we are not only listening to stars, but also to the echoes of the moment when everything began. The discovery of this background was itself an accident. In 1964, Arno Penzias and Robert Wilson were using a radio antenna to study signals. No matter what they did, they could not eliminate a faint hiss. They checked their instruments, cleaned away pigeons nesting in the horn, recalibrated endlessly. Yet the hiss remained steady, universal, coming from every direction. Only later did they realize what they had found, the afterglow of the Big Bang itself. What they mistook for noise was the most profound signal of all, a whisper from the dawn of time. The radio sky, in its quiet persistence, had offered them a gift beyond imagination. Through radio astronomy, we have also learned that our galaxy is filled with magnetic fields, invisible threads shaping the motion of particles and gas. These fields hum in radio waves, guiding cosmic rays, sculpting the spiral arms of the Milky Way. They are unseen hands, delicate yet powerful, weaving order into the vastness. The radio sky reveals them, showing us that even emptiness is not void but alive with structure. Every frequency adds a new dimension to the universe, every whisper another layer of truth. Perhaps the most haunting possibility is that radio waves may carry the voices of others. For if we can listen across billions of light years, then so too could others listen. The search for extraterrestrial intelligence, or SETI, is built upon this hope, that somewhere another civilization has sent its own whispers, deliberate or accidental, across the stars. We have scanned the sky for signals that differ from nature's hum, patterns that suggest intention. So far, no definitive message has been found, but the search continues. Each night, radio telescopes turn their ears to the stars, waiting for a voice that may never come, yet believing that if the universe is so vast, we may not be alone in it. Even without such signals, the radio sky connects us. It reminds us that every star, every galaxy, every atom participates in the same conversation, radiating energy across space. We are part of that dialogue, both as listeners and as speakers. Our broadcasts, faint though they become, add to the cosmic symphony. Long after our words have faded on Earth, their echoes will still travel outward, faint but persistent, carrying our presence into the dark. Somewhere, someday, those signals may be caught by a distant ear, and in that moment, two civilizations will share a silent recognition. We are not alone. Radio telescopes are growing more sensitive, more vast, more capable. The square-kilometer array, now under construction across deserts in Australia and South Africa, will be the largest radio telescope ever built. Its countless antennas will listen with unparalleled depth, tracing hydrogen across billions of years, mapping the first galaxies, catching bursts too faint for any other ear. It will be a new stage of listening, a new way of hearing the universe's song. Through it, we will listen more deeply than ever before, learning not only about the cosmos but also about ourselves, about the questions we carry into the night. To stand beside a radio dish is to feel both small and immense. The dish curves upward like a white petal open to the sky. You cannot see what it hears, yet you know that waves are falling upon it, invisible streams of memory arriving after journeys longer than time itself. You feel the wind on your face, the earth beneath your feet, and you realize that you are part of this act of listening, that your own body too is made of atoms that once glowed in stars, atoms that once hummed in waves. The radio sky is not distant, it is within you, a hum of belonging woven into your very bones. The poetry of the radio sky is that it expands the senses. We, who are bound by sight and sound, learn through radio that the universe offers more than either. Art is not limited to what we can see or hear naturally. It is vaster, richer, filled with frequencies we can only detect with instruments. In listening, we are humbled. We realize that our senses are small, but our curiosity is vast, and with it, we can extend our reach. The radio sky shows us that the universe is always larger than we think, always more than our eyes reveal. And so the whispers continue. They move through us as we sleep, as we wake, as we live our brief lives beneath the stars. They carry the pulse of neutron stars, the blaze of quasars, the breath of hydrogen, the echo of the Big Bang. They carry mysteries not yet solved, voices not yet heard, truths not yet understood. The radio sky is never silent, never still. It is a song written in waves, played across eternity. And we, with our patient ears, are only beginning to learn the melody. To close your eyes and imagine the radio sky is to imagine an ocean of hums and pulses, stretching beyond time. It is to imagine the universe as a great instrument, its strings vibrating in silence, its notes carried across the void. It is to feel that we are not separate from this music, but part of it, our very atoms humming in tune. The whispers of the radio sky are not foreign, they are kin, reminding us that we belong to the same symphony, the same unfolding story of light and wave, of silence and soundless song. And so the story ends softly like a fading echo. The radio sky still hums as it has always hummed, as it always will. Our telescopes still listen, our ears still reach outward, our hearts still long to hear. And though the whispers are faint, they are endless, carrying on long after we are gone. To listen to them is to accept that we are part of something vast and ongoing, a music that began before us and will continue beyond us. The universe is not silent, it has always been singing. And through the whispers of the radio sky, we are learning gently to hear its song. There was a time when every telescope was bound to Earth. They stood on mountains, under domes, straining through air that shimmered and shifted, through clouds that veiled the sky, through nights interrupted by storms or haze. The atmosphere, though it protected us, also blurred our view, bending starlight like water rippling a reflection. The stars twinkled because of this restless air, a beauty to the naked eye but a challenge to the telescope. No matter how perfect the mirror, no matter how patient the observer, Earth itself stood in the way. And so the dream was born, to lift our eyes beyond Earth, to place them in the silence of space, where nothing could disturb the clarity of starlight. The idea was simple but bold. If a telescope could be placed above the atmosphere, it would see the universe as it truly is, sharp and unbroken. No haze, no weather, no twinkle, only the pure light of the cosmos. It took centuries for this dream to become real, but when it did, the sky opened in ways we had never imagined. Telescopes beyond Earth became watchers, their mirrors and sensors turned outward, orbiting high above the planet, forever free of the distortions below. They were not only machines, they were extensions of human vision, our cosmic eyes released from gravity's grasp. The first watchers were humble. Small instruments rode aboard satellites, catching glimpses of the sun, measuring radiation, testing the waters of the sky. They proved that space was the perfect home for such instruments, a place where clarity reigned, and so the watchers grew. By the late 20th century, they had become full observatories, each one tuned to a different part of the spectrum, some to visible light, some to X-rays, some to infrared. Each revealed a new layer of the cosmos, each added depth to our understanding. Together, they created a symphony of sight, each wavelength a note in the great music of existence. The Hubble Space Telescope was perhaps the most beloved of these watchers. Launched in 1990, it carried a mirror just over 2 meters wide, small compared to ground giants, yet perfect in its freedom from air. At first, its vision was blurred by a flaw in its mirror, but astronauts carried on shuttles journeyed to repair it, giving it the clarity it deserved. Once corrected, Hubble's eyes opened with breathtaking beauty. It showed us galaxies tangled in cosmic dances, stars being born within nebulae, the delicate light of supernovae spreading across space. It peered into the deep past, capturing galaxies so faint they had never been seen before. With Hubble, the universe itself seemed to bloom before our eyes. Perhaps its most iconic gift was the Hubble Deep Field. Astronomers pointed it at a patch of sky that looked empty, a dark corner with nothing to show. They let it stare for days, gathering every photon it could. And when the image was revealed, it was filled with galaxies, thousands upon thousands, each one a universe of stars. What seemed empty was full beyond imagination. That single image changed our sense of scale, reminding us that the universe is not only vast but crowded, overflowing with light. The deep field was more than a photograph. It was a revelation, a message written in the quiet patience of a spaceborne watcher. But Hubble was not alone. Other watchers looked at the sky in ways Hubble could not. The Chandra X-ray Observatory revealed the high-energy universe, where black holes blaze, where supernovae explode, where galaxies collide with shockwaves invisible to ordinary eyes. The Spitzer Space Telescope gazed in infrared, piercing through dust to show the hidden nurseries of stars, the faint glow of planets around distant suns. Together, these instruments showed us that the universe is not only what we see, but also what lies beneath and beyond vision. Space became layered, each watcher adding a verse to the poem of the cosmos. The freedom of space allowed these watchers to listen as well as see. Telescopes tuned to ultraviolet traced the hot, restless regions around young stars. Instruments tuned to gamma rays revealed the most violent explosions in existence, bursts brighter than galaxies, flickering for only seconds but carrying secrets of distant cataclysms. Each wavelength offered a new story, each watcher a new perspective. They reminded us that the cosmos is not one song but many, played together across frequencies, harmonies too vast for a single eye to capture. To imagine these watchers is to imagine companions, drifting above Earth in silence, their mirrors and sensors open to the dark. They orbit tirelessly, day after day, never tiring, never closing their eyes. Below them, Earth spins, clouds drift, storms swirl, but above, the watchers remain steady, gazing outward. They are like monks of the sky, devoted to seeing, devoted to listening, devoted to patience. They do not blink, they do not sleep. They wait for the universe to reveal itself, photon by photon, wave by wave. And with each revelation, humanity changes. Space telescopes have shown us that planets are common, orbiting countless stars. They have shown us disks of dust where new planets form, echoes of how our own Earth was born. They have shown us galaxies at the dawn of time, faint smudges of light traveling for billions of years to reach us. They have shown us that the universe is expanding, still rushing outward from its fiery beginning. Each watcher has not only given us images, it has given us perspective, reshaping our sense of place. Imagine drifting alongside one of these watchers. There is no sound, only silence, no weight, only stillness. Earth glows below, blue and white, alive with weather and ocean. Beyond, the black is endless, yet filled with points of light. The telescope floats, golden panels glinting, its mirror aimed into the dark. Each second, light from stars and galaxies enters its eye, traveling into detectors that translate it into meaning. You are there in the quiet of space, watching with the watcher, seeing as no eye on Earth could ever see. In that moment, you feel the immensity of connection, the intimacy of distance bridged by light. The watchers remind us of something tender, that vision is not confined to where we stand. We can extend our senses, send them beyond ourselves, let them drift into the dark. A space telescope is an outstretched hand holding an eye into the unknown, trusting the universe to speak. And the universe does speak. It whispers in light, in waves, in pulses, and the watchers gather every word. They do not hurry, they do not demand. They are patient, and in their patience, the sky unfolds. In the end, spaceborne watchers are more than machines. They are symbols of longing, of the human desire to see more, to understand more, to belong to something greater. They remind us that though we are bound to Earth, our vision is not. We can send our eyes into the heavens, and through them we can see farther than ever before. They are our companions in curiosity, our partners in wonder, our mirrors turned outward. And as long as they drift above us, the universe will never feel quite so far away. When we look back across the history of astronomy, the launch of space telescopes stands as one of the most transformative steps humanity has ever taken. For centuries, our vision was tied to the ground, bound by the air we breathe. Even on the clearest nights, starlight shimmered and blurred, broken by turbulence and haze. Space telescopes changed everything. They lifted our eyes above the veil into the stillness of orbit, where light arrives as it truly is. With that freedom, the watchers became our clearest eyes, revealing not only more detail, but entirely new worlds of discovery. Hubble was the first to capture the world's imagination, but it was not alone for long. In 1999, the Chandra X-ray Observatory opened its mirrors to a universe invisible to human sight. X-rays, absorbed by Earth's atmosphere, had always been hidden from GR. Sound-based telescopes. In orbit, Chandra could see them clearly, mapping the violence of space. It showed us the glowing remnants of exploded stars, the fierce jets from black holes, the hot gas filling clusters of galaxies. In its images, we saw energy at play on scales both beautiful and terrifying. The universe was not only a place of calm starlight, but also of storms and fire, and through Chandra's vision, the unseen became seen. Not long after, the Spitzer Space Telescope joined the watchers. Tuned to infrared, it revealed the warmth of objects hidden from visible light. It looked into clouds of dust where stars were forming, where planets were coalescing from gas and stone. It traced the faint glow of galaxies far beyond the reach of optical telescopes, their light stretched by expansion into the infrared. Spitzer turned darkness into illumination, showing us that what appeared empty was often alive with structure and creation. It revealed not only where stars were, but where they were being born, not only what galaxies were, but what they were becoming. Other watchers joined, each with a different voice. The Compton Gamma Ray Observatory listened to the brief, brilliant flashes of gamma-ray bursts, the most powerful explosions in the cosmos, thought to mark the birth of black holes or the collisions of neutron stars. The James Webb Space Telescope, launched much later, unfolded its golden mirrors in deep space, tuned to infrared with unprecedented sensitivity. It looked back further than Hubble ever could, capturing galaxies forming only a few 100 million years after the Big Bang. With Webb, we are not only seeing deeper, we are seeing closer to the beginning of time, closer to the first sparks of structure in a universe once filled only with light. The collaboration of these watchers is perhaps their most beautiful quality. Alone, each telescope reveals wonders. Together they form a chorus, each wavelength adding harmony to the cosmic song. A galaxy studied in optical light shows its stars. Viewed in infrared, its hidden dust lanes glow. Seen in X-rays, its black hole blazes, jets firing into the void. In radio, its gas sings, tracing the threads of its structure. No single watcher tells the whole story. Only together do they reveal the fullness of truth. In their unity, we learn a lesson for ourselves. That understanding comes not from one voice, but from many, each adding to the whole. The watchers also remind us of fragility. They are marvels of engineering, but they are also vulnerable, drifting in the harshness of space. Hubble needed repair, astronauts traveling to it to give it clarity and life. Spitzer's cooling system eventually ran dry, limiting its sensitivity. Compton fell silent, its mission ended. Even Webb, with its golden mirrors, relies on delicate shields to stay cool and on careful alignment to keep its vision sharp. These machines, though mighty, are temporary. They will serve for decades, perhaps, but not forever. Yet even in their impermanence, they leave a legacy. The images they give us endure, their revelations etched into human knowledge long after their instruments fall quiet. Consider the Hubble Deep Field again. The patch of sky it observed was unimaginably small, yet within it were thousands of galaxies. Now imagine multiplying that field across the entire sky. If every tiny patch holds such richness, then the universe is teeming with galaxies, more than we can count, more than we can ever visit. This truth is not abstract, it is intimate. It tells us that our night sky is not sparse but overflowing, that our place in the cosmos is not lonely but surrounded by endless neighbors. Hubble showed us not only the grandeur of the universe, but also its generosity, its abundance. It reminded us that even the smallest glance holds wonders. The space watchers also helped us discover worlds around other stars. With their sensitive instruments, they detected the dimming of starlight as planets passed before their suns. They measured the faint warmth of distant worlds, glimpsed their atmospheres, even traced molecules like water and methane. These were not Earth-like twins, not yet, but they were proof that planets are common, that our solar system is not unique. Each discovery was a step toward answering the oldest question: are we alone? The Watchers did not give us a final answer, but they showed us that the universe is filled with possibilities, each star a potential home, each world a potential story. There is poetry in how these watchers extend our senses. On Earth, we see in a narrow band of light. In space, telescopes see beyond that band into realms we cannot imagine without them. They are not only extensions of sight, they are expansions of imagination. Through them, we have learned that the universe glows in many ways, that each frequency carries meaning, that reality is layered like a symphony. Without them, we would live in a smaller universe, a flatter univ. RSC, with them, we live in one that is vast, multidimensional, alive with voices we are only beginning to hear. Imagine drifting in orbit beside one of these watchers. Below, Earth glows with oceans and clouds, but above the dark is infinite. The telescope floats with you, panels outstretched, mirror gleaming. It is quiet, utterly still, save for the slow turning to follow its target. No air distorts its view, no clouds pass in front, no twinkling disturbs the stars. Every photon that enters is pure, direct, untouched by atmosphere. You realize that the telescope is not only a machine but a presence, a silent companion that listens without pause, without distraction. In its patience, you feel calm, as though the cosmos itself were inviting you to see without haste, to wonder without urgency. The watchers are also symbols of courage. To build them is to risk much, to trust that what we send into space will survive, unfold, and see. The James Webb Space Telescope was folded like an origami flower, launched atop a rocket, then opened slowly over weeks, each step a test of precision. Failure could have meant silence, but success meant vision beyond anything we had known. That courage paid off, giving us images of galaxies forming in the young universe, of planets glowing in alien suns, of nebulae blooming with new stars. It is a reminder that discovery often requires faith, that to see farther, we must dare to reach farther. The spaceborne watchers are not only our eyes but also our mirrors. They reflect our desire to know, our refusal to remain blind, our longing to belong to the universe we inhabit. They carry our questions outward, and in return, they bring us answers written in light. They remind us that vision is not a passive act. It is an expression of wonder, a reaching out, a listening. And in their clarity, we find not only the cosmos but also ourselves, reflected in the patient gaze of machines we built to extend our sight. In their silence, drifting above Earth, they watch. They will continue to watch, gathering light, gathering truth, gathering beauty. And as long as they do, the universe will continue to unfold, layer by layer, into our awareness. The spaceborne watchers are not only instruments of science, they are guardians of wonder, keepers of vision, companions of curiosity. They are our cosmic eyes, lifted beyond Earth, forever open, forever waiting. The universe stretches endlessly before us, and the curiosity that drives us to look upward refuses to wane. If the spaceborne watchers have shown us what lies beyond Earth's atmosphere, the next generation of instruments promises to reveal what we have yet to imagine. New telescopes, larger and more sensitive, will push into wavelengths never explored and depths never reached. They will uncover faint galaxies, distant quasars, and hidden structures of dark matter, painting a picture of the cosmos that is both precise and expansive. The future of cosmic sight is not merely in seeing farther, but in seeing more fully, in observing the universe as a complex, interconnected web of light, energy, and motion. One avenue of advancement lies in multi-messenger astronomy, where telescopes collaborate with detectors of other cosmic signals, gravitational waves, neutrinos, and cosmic rays. While light has long been our primary messenger, these other signals offer unique insights into violent and hidden processes in the universe. When two neutron stars collide, they not only emit ripples in space-time detectable as gravitational waves, but also flashes of gamma rays and bursts of visible light. Observing such events from multiple perspectives allows astronomers to reconstruct their physics with unprecedented accuracy. In essence, the next telescopes will not work in isolation, but as parts of a cosmic orchestra, each instrument adding to the resonance of discovery. Technological innovation is at the heart of this progress. Adaptive optics, once a cutting-edge solution for ground-based telescopes, now promises even greater clarity when combined with next-generation space observatories. Mirrors are becoming lighter, more precise, and capable of self-correction, bending and adjusting to maintain perfect focus despite thermal fluctuations or mechanical stress. Detectors are more sensitive, capable of capturing single photons across vast ranges of wavelengths. Spectrographs can dissect light into finer details, revealing the chemical fingerprints of distant worlds and the dynamic motions within galaxies. Even the way telescopes are launched and deployed is evolving, with modular designs and in-orbit assembly offering the possibility of structures far larger than any single rocket could carry. The James Webb Space Telescope has already set a precedent, and future observatories will surpass its capabilities in both scale and specialization. Telescopes like the Nancy Grace Roman Space Telescope will conduct wide-field surveys, mapping enormous portions of the sky to understand dark energy, the mysterious force accelerating cosmic expansion. Other missions aim to detect and characterize Earth-like exoplanets, searching for signs of atmospheres that might support life. The combination of high-resolution imaging, precise spectroscopy, and coordinated observation campaigns will allow humanity to piece together a coherent understanding of planetary systems beyond our own, offering a glimpse of the diversity and complexity of life's potential stages throughout the galaxy. Meanwhile, radio astronomy continues to expand its reach. Arrays of antennas, spread across continents or even in orbit, work together as interferometers to simulate apertures larger than any single dish could achieve. They map the invisible structures of gas clouds, trace magnetic fields threading through galaxies, and detect faint whispers of cosmic phenomena that light alone cannot convey. Projects like the Square Kilometer Array promise to revolutionize this field, providing maps of unprecedented depth and resolution. By listening to the universe across multiple channels, astronomers can detect patterns and correlations that reveal the underlying architecture of cosmic structures, bridging the gap between theory and observation in ways previously thought impossible. Space telescopes themselves are becoming more versatile. Instruments are being designed for long-duration missions, capable of autonomous operation for decades. Swarms of small, specialized satellites, sometimes called constellations of mini-observatories, can observe simultaneously in different wavelengths or focus on multiple targets across the sky. This distributed approach allows more continuous monitoring of transient events like supernovae, gamma-ray bursts, or rapidly evolving exoplanets. The universe is not static, and these future observatories recognize that dynamic observation is essential to fully understand the changing cosmos. By capturing events in real time, they transform astronomy from a static study into a living, evolving dialogue with the stars. Interdisciplinary collaboration will be as crucial as technological innovation. Astrophysicists, engineers, computer scientists, and data analysts work together to maximize the potential of these instruments. Machine learning algorithms sift through torrents of data, identifying patterns too subtle for human eyes to detect. Simulations and theoretical models help guide observations, suggesting where to look and what phenomena might be detectable. This synergy of human intellect and mechanical precision ensures that the telescopes not only collect data, but interpret it in ways that advance knowledge. As instruments become more complex, so too does the ecosystem of people and processes that enable them to function as extensions of human perception. The importance of wavelength diversity cannot be overstated. Just as a painter uses multiple colors to convey depth and emotion, astronomers rely on a spectrum of light to uncover the universe's stories. Ultraviolet, X-ray, infrared, and radio each reveal different aspects of celestial phenomena. The choice of wavelength shapes what we can see. Hot, energetic processes shine in X-rays, cooler dust and star-forming regions glow in infrared, neutral hydrogen clouds hum at radio frequencies. The careful orchestration of these instruments allows astronomers to assemble a three-dimensional, multi-layered view of cosmic structures. Each new wavelength explored offers the potential for discovery, reminding us that the universe still holds secrets that only patience and innovation can unveil. Looking beyond our immediate solar neighborhood, future telescopes aim to resolve details of galaxies billions of light-years away, studying their formation, evolution, and interactions. By comparing nearby galaxies with those from the early universe, astronomers can trace the history of cosmic structure, understanding how stars, planets, and galaxies assemble over time. These observations challenge and refine theoretical models, creating a feedback loop between observation and prediction. Every image captured, every spectrum analyzed, is a step toward answering profound questions about the origin of matter, the evolution of cosmic architecture, and the ultimate fate of the universe itself. Exoplanet exploration will continue to be a frontier of profound significance. Beyond mere detection, the focus shifts to characterization. Future instruments will be capable of measuring atmospheric compositions with fine detail, detecting water, carbon dioxide, methane, and potentially biosignatures. Spectral analysis combined with temporal monitoring can reveal weather patterns, climate cycles, and even seasonal variations. Each discovery contributes not just to science, but to humanity's sense of perspective. We begin to understand our own planet in relation to countless others, situating Earth within a vast, diverse, and dynamic galactic ecosystem. SPAC. E-telescopes, in this sense, act as both explorers and philosophers, mapping the physical universe while provoking existential reflection. Humanity's gaze will not remain confined to passive observation. Concepts for space-based interferometers, telescopes spanning thousands of kilometers using coordinated arrays, promise resolution so sharp that individual planets in nearby star systems may be imaged directly. Missions designed to block out starlight, known as coronagraphs or star shades, will allow the faint glow of exoplanets to emerge from the overwhelming brightness of their suns. These techniques, still in their infancy, represent the next horizon of cosmic vision, literally peeling away the glare to reveal what has always been there, just out of reach. In doing so, they continue the legacy of the Hubble, Chandra, Spitzer, and Webb telescopes, pushing humanity to see further, clearer, and deeper than ever before. The technological and conceptual progress of telescopes mirrors the evolution of human thought. Just as we once needed to leave Earth to see the stars more clearly, we will increasingly need to leave our planet to understand the universe's complexities. Observatories may be positioned at Lagrange points, orbiting moons, or even on the surface of distant planets, each location offering unique advantages for capturing light and minimizing interference. The challenges are immense: harsh environments, logistical constraints, and the fragility of instruments, but the rewards are profound. With each deployment, humanity stakes a claim in the quest for understanding, affirming that curiosity is a force capable of spanning space and time. At the same time, future telescopes serve as a reminder of interconnectedness. Data collected from these instruments is shared across continents, analyzed by teams spread worldwide. Observations in one hemisphere complement those in another. Open access archives allow scientists, students, and enthusiasts to explore the universe without ever leaving Earth. In this way, the cosmos becomes a unifying frontier, one that transcends national boundaries and individual limitations. The universe is vast, but in observing it together, we create a shared experience, a collective memory of wonder and discovery that is uniquely human. Ultimately, the telescopes of tomorrow are more than tools, they are symbols. They reflect our ambition, our ingenuity, and our relentless desire to know what lies beyond the horizon. They capture light that has traveled millions or billions of years, allowing us to witness events from distant epochs as if they were happening in the present. They show that even in the face of immensity, humanity possesses the capacity to reach out, to understand, and to marvel. Each instrument, each mission carries a promise that the cosmos is not an unknowable void, but a landscape of insight, ready for those who choose to see. As these instruments extend the boundaries of vision, they challenge our perception of time and space. Looking at galaxies billions of light years away is, in essence, looking back in time, seeing the universe as it was long before Earth existed. Stars that have since died continue to shine in their light, traveling across the void to meet our telescopes. The past and present converge in these images, merging cosmic history into a single frame. With each revelation, humanity learns that understanding is both an observation and a meditation, a dialogue between the mind that